are not followed in the complete environment, all that contributes to your complete big data gap. Okay, so it is not only a storage which is creating this problem. And that is what we are talking about. What we are doing majorly is, and if you see app data gap, this is some of the analysis. 47% of people are saying 10% of his time in a day-to-day activity he is losing because this app data gap. I'm losing that time because I'm not taking that left turn on time. And then I have to go straight, take a U-turn and come back again. That 10% people are saying my 10% of my time is losing. This is 47% people are talking about. People are talking about I'm getting less tolerant with 59% people are talking about I'm getting less tolerant. You click your cell phone, you click on Facebook and it is not opening up. You click on your WhatsApp, it is not opening up. How much patience we have now? We lost that patience. We say it has to come fast. Why there is 4G? Why there is not able, I'm not able to browse my complete data. So basically we are becoming more and more intolerant in terms of getting the data from the application, from the back end. What we are saying is with our architecture, we are bridging that gap. So with the all-flash arrays, everybody talking about all-flash array giving you high performance. We have all-flash and hybrids clubbing together and we come out something called unified flash fabric, wherein your all-flash array and hybrid array can work in a single storage box. So you can decide which application can sit on all-flash and which application can sit on the hybrid. So how much is the performance? Everybody talks about the numbers, so I just want to put it across. How much is the performance we are talking about? We are talking about 1.2 million IOPS. We are talking about 8 petabyte of capacity from all-flash array itself. And the latency is less than 1 millisecond. So when you say app data gap, I'm reducing that latency or reducing that gap which is less than 1 millisecond now. Okay? How much I can go up to? I can go up to 8 petabyte. How much I can go up to in terms of IOPS? I can go up to 1.2 million IOPS. Now, this is one part of it. The second part to this is how I scale, because that is something which is very crucial. I start small and then how my complete infrastructure will grow when I grow in my business. So basically we start small. You can increase your capacity by adding the expansion shelf. It is a standard practice. But then, adding the expansion shelf, but then you can change your controllers online to change your IOPS online. So basically, you start small as 35,000 IOPS. You go up to 1.2 million IOPS without adding a single spindle. And this is what the differentiator for us is. We are saying your IOPS, your storage performance, irrespective of the backend spindles. It is dependent on the CPU and memory which we provide onto your model. And that is what the big advantage for us is. So instead of adding a single spindle at the back end, I can change my IOPS to a 4 times. So we are talking about something around 1.2 million IOPS and 8 petabyte of capacity with this kind of architecture. Now, when we say I can do all flash and adaptive together. So basically, if your application is Oracle and SAP, and then you have reporting infrastructure on the hybrid array, I can move this, say, month end. I want to move it, my reporting has to be as fast as possible. So I can move this transparently without your application having an impact. This is again very, very crucial. So I can do this without application understanding that, okay, I'm moving from hybrid to all flash or from all flash to hybrid. This is, application is not aware of it at all. So basically your infrastructure, we are utilizing your infrastructure maximum by using this kind of transferring of your volumes from one tier to the other tier of the storage. Now, when we talk about the TCOs, we are doing 66% lesser TCOs, so we are doing data reduction. We are doing 5x of data reduction. So how we do is, we do something called, we are using 3D NAND drives for your all flash. So if you see rightly, when there was some discussion happened recently which talks about my SSDs becoming the write cycle of the SSD and read cycle of the SSDs and all the stuff, we are using 3D NAND drives to give you maximum resiliency in that case. We are using 3D NAND drives to give you more capacity, okay, as compared to a SSDs which is very having that write amplification problem. So we are resolving that write amplification problem by using 3D NAND drives. We are compressing your data big time. We are deduplicating your data big time. So 5x reduction in your complete environment. And then we are taking care of your backup, DR, and archival. So there is nothing called a separate software required to take a backup, or there is no separate software required for doing a DR kind of activities. It is bundled together. So operating system has everything what a complete infrastructure will require. Enterprise class infrastructure, whatever it requires, my complete operating system will have all those informations, all those softwares required to utilize and get into that infrastructure. 3D NAND drives, what is the use of 3D NAND drives? 7 years of SSD lifespan. So basically, we understand that the SSDs, the earlier SSDs has its own lifespan problem. So we are going ahead with the new technologies. We are going ahead with the 3D NAND drives, which gives better life cycle than a standard older SSD drives earlier. Any queries, sir? Sorry. So we go with the 3D NAND drives, we go with the increased performance. We are giving you more usable capacity by doing the reduction in the capacity by using inline deduplication, doing inline compression of your data. So basically, this is what we are talking about. I'm doing compression, which is variable block compression. We are doing variable block deduplication, compressing and deduplicating your data 5x time. So we are reducing your footprint 5x time. And then the next advantage for us is you start with your all-flash array into your production and do a DR onto a hybrid array, which is normally not possible in a traditional approach. What we are saying is all-flash array can replicate to a cost-effective hybrid array on the DR side. Okay? There is no software required. This is storage-to-storage replication, block level, incremental replication happening. Okay? Major advantage, because you don't have to have a complete same environment of all-flash on the DR side. Not required. You can have all-flash on the production. You can have hybrid on the other side. It can be possible. So basically, when you go to the traditional approach, this is how it looks like. You need to do a D2D backup, then you need to do a replication. So tier 3 is required for disaster recovery as well as backup purpose. What we are saying is, in the storage itself, you can do snapshots and then replicate that snapshot into the DR side. So you don't require any other storage or any other component to do this DR as well as replication. Everything is integrated in the Nimble storage itself. So you require 2 Nimble storages. From production, you just replicate into the DR side, and you can have multiple different policies of snapshot onto the DR side. There is no dependency that, okay, your production can have different snapshot strategy, your DR can have a completely different snapshot strategy. And then you can do a cloning also. So basically what we are saying is, in case you want to give these snapshots for test and development, or you want to do it for backup purpose and all those, you can do it by doing a clones of it. You can have multiple clones of that snapshot, and you can give it, again, no space required for it. It is just a copy of snapshot. So you don't require a space to get this cloning done. Resiliency part, we are committing 99.9997%. So 5 nines and 7. With the latest operating system, we are committing 6 nines. So basically, we are committing you the 6 nines in the environment. We are committing you triple plus parity rate. This is again huge advantage, because normally if you talk to a traditional approach, they will be giving you maximum protection is 2 drive failure. We are giving you simultaneous 3 drive failure in your environment, still your data is protected. So we are going one step ahead. We are talking about triple plus parity. We are integrated, so all the backup softwares and snapshots and replications are integrated in the operating system. And encryption, which is again unique feature in this case, is normally in case you want to do in your environment, you want to do encryption, you have to have SED drives, which is self-encrypted drives, or you have to have a controller doing this encryption. What we are saying is, you can select a specific volume and you can do encryption on the fly. There is no requirement saying, okay, encryption can be treated as a completely different software feature requirement itself. So we can do encryption on per volume level. These are some of the models. I just want to highlight that, okay, we talked about these models. We talk about the IOPS. We talk about the performance on day one. We are not dependent on the back-end spindles to give you IOPS. So basically what we are showing here is you can start with 35,000 IOPS. You can go up to 300,000 IOPS in all flash without having any configuration specification in terms of back-end spindle. You can have 11 TB of capacity. You can have 2 petabyte of capacity. Your IOPS remain the same. And then, since I am media agnostic, when we talked about the hybrid array, your performance remains same. So 35,000, 120,000, 230,000 IOPS, I can give you from the same CPU and memory models which we are configuring. So basically, all flash array gives you less than 1 milliseconds of latency, and hybrid gives you less than 3 milliseconds of latency. That's it. So the two difference between the two models is the latency component, and the IOPS remain same as per the data sheets what we are talking about. Now, earlier speaker talked about the big data analysis and all those stuff. What we are doing is, normally, if you see the support infrastructure, many people does it manually still. So you send the logs to the OEM support. OEM support will analyze that log and tell you what the problem is. What we are doing is, every array of Nimble will have software sensor inside the operating system. So you don't have to put the logs to our support center whenever there is a problem. What we are doing is, every 5 minutes, I'm collecting the logs, almost 20 million to 100 million software sensor data. Every 5 minutes, I'm collecting that particular logs. And what we have is the backend. So how much we are collecting? In 4 hours, we are collecting almost stars of the galaxy. In 4 hours, we are collecting almost stars of the galaxy is the huge data we are collecting. And every array of Nimble puts that data into a big data analysis at the backend. So we have a capability wherein we compare those two snapshots, and if there is abnormality between these two snapshots, we open up a case. Okay? Completely different way of supporting. If you compare that with the traditional approach, we are complete different in the support. We are complete different in the support. We are more proactive. We are more proactive than anybody else, because we are just comparing the snapshots. There is somebody at the back end who is observing your array 24/7, 365 all the time. And this is every 5 minutes logs. So every 5 minutes somebody is observing your array. That is a huge advantage as compared to a traditional approach. We don't have to shift any logs. There is no log shipping at all. Okay, so in case of a problem, we are not asking for logs at all. We don't have L1, L2 engineers. We have only L3 engineers available, which will talk to the customer, which will talk to the client and gets the problem resolved. So we are fastest in resolution time. We are fastest in resolution time. We are fastest in understanding what the problem is. We are fastest in finding out the root cause of that problem. And then, since I have the complete logs with me, what we do is, we take that logs, we do an analysis part of it. We do trend analysis of it. We do, we can talk to each and every volume and find out what is the read-write ratio of each volume, how many IOPS I am doing per volume, how much is the cache hit ratio of each volume. I can do all that with this info site, okay? Which is again part of the operating system. You don't have to spend anything. You don't have to put any extra infrastructure to get this info site data. Every 5 minute data, my array will be putting it to my backend big data analysis engine. 2 slides. So I'll just skip this. The major slide what we talked about is, we are talking about what InfoSight talks about is the visibility beyond storage. We can get integrated with the vCenter, and I can find out in your VM infrastructure if there is any latency problem, if there is any host related problem, is there any network related problem, we can identify that. And then we can put it to your administrator to work on it. So basically, when we talked about the Nimble storage, we work very closely with all these application vendors and hypervisors, as well as we work very closely with the data protection guys like Veeam and Commvault and Symantec to get the data backed up into disk to disk backup. No licenses. So this is my last slide, which talks about no licenses at all. All the softwares are part of the operating system. So we are not selling any license at all. We are giving you by default deduplication and compression. So there is nothing called a separate license or performance impact because of the compression and deduplication. It is by default enabled, and still we commit to you some specific IOPS, as I already showed you in the data sheets. We commit to you the latency part. IOPS, everybody talks about IOPS, nobody talks about the latency. We commit to you the latency part also. And then it is just plug and play. There is nothing called RAID configuration, how many spindles I need to configure and all the stuff. There is nothing on that side. By default, you just plug and play. We take care of your data protection. We take care of your volume creation and all those. You just have to say plug and play and connect it to your infrastructure. And then InfoSight gives major advantage for you. We do proactive analysis through the InfoSight part. So any queries, this is what I have. I think out of my time. But then any queries, anything, let me know. I'm there for the lunch. So in case anything, just let us know.
Thank you. Thank you very much, Mr. Sanavne. And can we have a huge round of applause, ladies and gentlemen? Our last two speakers coming up, but before that, a reminder, you've got feedback forms on your table. Please make sure you fill up these feedback forms at the end. When we finish with all the sessions, you can hand them back at the reception, and they get converted into a little gift for you. All right, so before I invite my next speaker, one quick question. There is only one, what do you call it? I'm not getting the word. Yeah. You know, there is only one, I'm not getting the word. Okay, I'll try something else. You know, there is a girl who has just learned to drive. She goes down a one-way street, but in the wrong direction. There is a policeman who is standing over there at the end of the street, but he does not stop her, nor does he penalize her. Any idea why? She is walking. I like that. Give him a very big hand. Excellent. Okay, so your table gets another point for that. So, ladies and gentlemen, our next speaker coming up, Mr. Vinci Quatra, Distribution Account Manager, Access Communications. He's going to be speaking about securing the next generation workplace. And Mr. Vinci Quatra for you. Can we have a huge round of applause? Thank you.
Hello. Thank you very much. Thank you. I think we have discussed a lot on data, how to protect the data, how to use the data, how to analyze the data. Now I will take a few slides on surveillance. We are into IP cameras. We are the one who started IP cameras in the year 1996. Till starting from that year, till then whatever technologies you are facing or what you are listening in IP cameras, we are the inventors of that technologies, and we are the one who started that technologies and become the followers for others. Now, this is our worldwide presence that we have. We are headquartered in Sweden. In India, we are headquartered in Bangalore. We are approximately 20 people in India, considering pre-sales, post-sales, sales, marketing, everything put together. In Delhi, we have our office at Jasola. We have a team of 3 people. This is little about Access. Total strength is around 1,600 plus people. Our total sales is 4.7 billion US dollars, which sold of only IP cameras that we have. We recently started our NVR solutions. That's a software-based solutions that we have for completing the ecosystem of the cameras. This is a little bit innovations that I want to talk about on Access. As I told you that we started in the year 1996 with the first IP camera. After that, we started we innovated our encoders. That technology is H.26 format that we are using these days on whatever base using that. After that, new technologies like Access solutions on thermal cameras. What about light funnel technology that is a very unique with Access. Again, zip stream technology that helps us to reduce the bandwidth as well as storage when we are using the surveillance cameras in our systems. High definition TV standards, because these are the standards which are being made as per SMPT committee, that is television standard committee, that is guidelining, which is giving guidelines for making these standards like 1 megapixel, 2 megapixel.